Hi, we are in Chapter 3, Section 2 now, looking at graphs of linear equations. So you remember in the last section you just went over, looking at plugging in domain, the x's, getting out the range, the y's. Now we're going to be using those points to look at a graph. If you follow along, page 107 in your book, we'll look at reviewing some graphing. On page 107, you'll see many bolded words. What I want you to do is take a moment, scan through them, and write down any new vocabulary for you. So some of this will be review. You might know what a coordinate plane is. I do want you to remind yourself about first, second, third, and fourth quadrants, where they're located, and also x-axis, y-axis, coordinate pairs, one-to-one correspondent, etc. So take a moment on page 107 and add the vocabulary from this page to your notes. Now examples 1 and 2 in your book are reviewing how to graph coordinate pairs in example 1. And example 2 takes what you were doing in the last section, rearranging a variable, and then plugging in the domain to find the range, plugging in x to find y. Now the one more step is graphing the points that you've been finding. What I'd like to show you now is example 3. So I'm on page 109 looking at example 3. It's asking us to graph this equation. You'll notice that this equation is what we're calling standard form. I've got a coefficient x, coefficient y, and then another constant, a number by itself. So ax plus by equals c. In this case, just to identify, we've got a is 2, b is -3, and c is -9. So as we move forward, it's going to be important to be able to recognize this a, b, and c. So we're putting it here now. Now one of the suggestions that I have for you when we're looking at graphing an equation, we could choose any number to plug in for x and figure out what y is. Likewise, plug in for y and figure out what x is. I like zeros. The zeros kind of make the whole equation easier. So I might choose to plug in 0 for x. I want to see what happens when I plug in 0 for x. So I'm just going to note that to myself. I'm going to make x 0. I'm choosing it because it's going to make this whole thing easier. So I'm just going to rewrite this equation. I've got 2 times 0 now, minus 3y equals a -9. I'm going to solve that out for y. So once I plug everything in, I look and I see that I've got 2 times 0 goes away, so I've got -3y equals -9. Then dividing both sides by -3, I get y equals 3. So I'm going to put my solution into this coordinate point notation. Got 0 for x and 3 for y. So I'm going to come over to this graph here. I'm going to plot this point. I'm going to go, let's see, x moves 0, so I'm not going to move anywhere left or right. I'm going to stay somewhere on this line because x is 0. And then I've got a +3 for y, so I go up 1, 2, 3, and my point is right here. And then I'm just going to label it 0, 3. There we go. Now in order to draw a line, I want to have 2 points. So I'm going to choose another point to plug into the original equation in order to solve for another point. I could choose another x easily, but I like to make things easy for myself, as easy as possible. So now I'm going to choose 0 for y. I'm going to say this time that y equals 0, because it's going to cancel. You noticed when I had x equals 0, it canceled out this whole term here. So the same thing will happen when I plug in 0 for y. Cancel this whole term out, and it'll be super easy to solve for x. So just plug in and solve the rest of the equation. 3 times 0 goes away and it just equals 0. Then 2x equals negative 9. Dividing by 2, I get x is negative 9 divided by 2, negative 9 halves. And so here that means I've got a coordinate point of negative 9 halves, 0. So bringing that over to my graph, I see here that I've got a 0 for a y coordinate, so what that means is I'm not moving up and down at all. I'm staying on this axis. I've got a negative x value, so I'm moving in the negative direction. And I've got 9 halves. 9 halves is an exact fraction, but if we're to estimate to decimal, it would be 4.5. So I'm going to go over 1, 2, 3, 4, and then another half, and put my point there, right here. And then I'm going to label that. I've got negative 9 halves, 0. So now I've got 2 points, and from here I can use a straight edge, which I don't have unfortunately. You can use a straight edge to connect these points. So it's going to look something like this. Now what you could do, especially if you have graph paper, is you can find another point, maybe 3, 5, estimating, 3, 5. I could plug 3 for x, 5 for y, and check to make sure that this equation still holds. This would be a way to check my work, making sure that this line does indeed represent that equation. Now if we look at example 4, again on page 109, we'll notice that we've got 2 interesting equations. One is that we've got y equals 4 that we're wanting to graph, and another one is x equals negative 5 halves. There are a few different things going on here. One is that you'll notice that in each equation there's only one variable. You'll also notice that that variable is equal to a constant value. What's going on the graph here is that y equals 4 happens right here on the axis, but it also happens right here and right here. So in other words, it doesn't matter what x value I have, y is always going to equal 4. So I'm going to get a straight line that's parallel to the x-axis that just goes through each value of x for which y equals 4. Likewise, the same thing is happening with this x equals negative 5 halves. This entire line is where x equals negative 5 halves. The y values change. The y values change. But that doesn't matter because my x values continue to be negative 5 halves. So this line is parallel to the y-axis. What your book uses to explain this is that we've got something going on, especially if we look at this one, this equation to start. We've got, let's see, we've got 0x plus 1y equals 4. So going back to that standard form where I've got ax plus by equals c, if I simplify this thing, then I'm going to have y equals 4, right? And I can check this graph by following the same process that it did in the last example, plugging in something for x, getting out y. And what you'll notice is that you get various points that form a straight line. Here, we might also notice, if we were to rearrange this and to look for slope in slope-intercept form, for example, I might, let's just follow this logic. I might subtract 0x from both sides, right? And then I'm going to have y equals 0x plus 4. And here, I'll remember that the number that comes right before the x is the slope, and we usually say slope is m. So here we've got a zero slope. Zero slope. One of the tricks that I've found, one of my mentor teachers again showed me, is that we've got this line, this horizontal line, and that's also the top of a z, right? Zero slope. So when we've got a y equals constant equation, means we've got zero slope. And zero slope is always going to mean that we have a horizontal line. Now let's apply the same logic. Let's apply the same logic to the other graph. So we're looking at x equals negative 5/2. So again, writing this in standard notation, I would have 1 times x plus 0 times y equals negative 5/2. Okay, so let's rearrange this and try to find some slope. So I'm going to, again, isolate y. I'm going to subtract 1x from each side. So that leaves me with 0, y equals negative x minus 5/2. But I can't have a coefficient in front of y, so I'm going to divide by 0, divide by 0. What? That is a huge, huge mistake. Can't ever divide by 0. So if I'm having to divide by 0 in order to find slope, right, in order to isolate, in order to get this y by itself, I'm dividing by 0? Huge mistake, mathematically speaking. Now my algebra is right, but something strange is going on. When I divide by 0, I'm actually putting myself in a situation where I'm getting undefined slope. Undefined. Okay? So whenever I have, what this means is that whenever I have an equation such that x is equal to a constant value, I'm going to have this thing undefined slope, meaning that something somewhere is getting divided by 0, and that just can't happen. It's against the laws of math. Now, if we're looking at a trick again, this is kind of cool. If we're looking at a trick, mentor-teacher trick, we've got this vertical line, and it kind of is the side of a u for undefined. So we're lots of different tips and tricks for trying to figure this out, but showing you the rationale behind identifying and talking about each of these slopes. So just shrink this back down so we can see them both side by side, right? So we've got 0 slope as a horizontal line and undefined slope as a vertical line.